When we talk about energy, it's so easy to get lost in the technical stuff, right? We talk about kilowatt hours, grid capacity, solar panel efficiency. But what if that's not the whole story? What if we've been missing the most important part? Today, we're going to take a step back from the pure data and start looking at energy for what it really is, a question of ethics, of justice, and of the very foundation of civilization itself. So, to really get started, let's frame the problem by looking at our world from a distance. Because from way up there, the story of energy inequality isn't told in charts or numbers. It's told in light.
I mean, just look at this. This single image says more than 1,000 reports ever could. You see these glowing arteries of light all across Europe, North America, East Asia, just brilliant constellations of cities. And then you see the vast, profound darkness over so much of Africa. This isn't a map of where people live. It's a map of who has power. It's the most stark, visual proof of our world's energy divide.
So how in the world did we get here? Well, for most of human history, our energy use was basically flat. The Industrial Revolution gave it a little nudge upwards, but look what happens right around 1950. It's an explosion. They call it the Great Acceleration for a reason. The curve just shoots almost straight up. This is the moment that built the modern, lit-up world. But, as we just saw, it wasn't built for everyone.
And this chart right here, this shows us exactly who is burning all that fuel. Way over on one end, you've got countries like Iceland and Qatar, using over 700 gigajoules per person. Now compare that to the average for the entire continent of Africa, just 14. That's not a gap, it's a canyon. And when you see a gap that wide, you realize this isn't just a technical problem. It is a profound question of global justice.
Okay, so how do we even begin to think about a challenge this complex in a structured way? Well, there's a really useful framework that we use called the energy trilemma. And honestly, it's the fundamental balancing act at the heart of every single energy policy decision being made on this planet.
The trilemma is really just a constant negotiation between three competing goals. The best way to think about it is like a triangle. You can decide to move closer to one corner, but when you do that, you're probably moving further away from another. Getting this balance right is the whole game. First up, we have energy security. This is the most basic question of all. Can you keep the lights on? It's all about having a reliable, uninterrupted supply of energy to meet your country's needs, not just for today, but for the long haul.
Second is energy equity. And this one takes us right back to that satellite image we started with. Is energy actually accessible and affordable for everyone? For a family in a crowded city and for a family in a remote village? Because if energy is too expensive or just isn't available, you're creating massive social injustices that block education and kill economic growth.
And finally, the third corner of our triangle is environmental sustainability. This is all about what you'd expect: minimizing our impact on the planet, reducing emissions, and, crucially, shifting our energy sources away from polluting fossil fuels and toward clean, renewable ones.
Now we have our framework. Simple enough, right? Well, not so fast. Trying to apply this trilemma in the real world is where things get messy. The path forward isn't a straight line. It's full of these counterintuitive paradoxes and really, really difficult trade-offs. There are no easy answers here.
Let's take the Jevons paradox. This one is fascinating and frankly a little frustrating. The idea is that as technology makes using a resource way more efficient, like a super fuel-efficient car or an LED light bulb, our total consumption of that resource can actually go up. Why? Well, because if something becomes cheaper and easier to use thanks to efficiency, we just end up using it more often and in more ways. It's a huge lesson. Efficiency is absolutely critical, but it is not a silver bullet.
And you can see different nations weighing this trilemma in totally different ways. Just compare France and Germany. Years ago, France went all in on nuclear power. They prioritized security and low-carbon sustainability over everything else. Germany, on the other hand, with its Energiewende policy, has poured money into renewables for sustainability. But by phasing out nuclear at the same time, they've had to burn more fossil fuels to maintain their security. Two rich, neighboring countries, two completely different answers to the same trilemma.
So to make this even more real, let's zoom in and look at how all these challenges play out in a developing nation. The Philippines is a perfect case study. It's an archipelago, more than 7,000 islands, and it is facing the full force of this energy trilemma head-on.
So let's start with where things are now, the legacy system. The Philippines does have some of its own fossil fuel resources, but if you look at the numbers, they're pretty small on a global scale. And what that means is the country has to rely heavily on expensive imports to maintain its energy security.
This is the starting point.
But now look at the other side of the coin. The potential for renewable energy here is just immense. We're talking about incredible, consistent solar and wind potential scattered all across the country. The raw ingredients for a totally new, clean, and local energy system are right there.
The big hurdle, though, is the infrastructure. This map shows the current system. It's all built around these big, centralized coal, oil, and gas plants, mostly clustered around the major industrial islands. The physical pipes and power lines we have today were all designed for yesterday's system.
And all that centralized power gets moved around through a national grid. But think about it. In a country made of thousands of islands, trying to run power lines out to every single community is incredibly difficult and wildly expensive. This is a massive barrier to energy equity, and it's why so many smaller communities are either underserved or completely off the grid. But this is where the opportunity is just staggering. That renewable potential we talked about, the best spots for solar and wind, isn't in one place. It's distributed all across the archipelago. This opens the door to a completely different future, a decentralized system of local microgrids, a system that could finally bring reliable power to remote communities, that's more resilient to typhoons, and that could achieve a level of energy equity the old system never could.
Now, seeing this kind of potential requires a really fundamental shift in how we think about the future. It's not about trying to predict what's going to happen. It's about deciding what should happen.
We have to shift our thinking from forecasting to something called backcasting. Forecasting is what we usually do. We look at current trends and just project them forward. Backcasting flips that script. It starts by defining the future we actually want. So for the Philippines, that vision might be 100% energy access, low emissions, and a resilient power grid. Then you work backwards from that vision and ask, okay, what policies, what technologies, what investments do we need to make starting today to get there?
And that brings us to you. As future environmental scientists, as policymakers, as educators, this isn't just some academic exercise. This is your mandate.
The real solutions are going to look a lot like this. It's not just about cool technology for its own sake. It's about technology in service of people. A solar-powered school isn't just making clean electricity. It's providing light for kids to do their homework, it's powering services for the community, it's creating local jobs. This is where technology meets equity.
So your work, your role really boils down to these three key actions. First, you have to critique. You have to be able to analyze and call out the injustices in our current energy system without flinching. Second, you have to synthesize. To really understand that there is no one magic bullet, but instead a whole portfolio of solutions. Solar, wind, better batteries, efficiency, even changing our behavior. And third, you have to formulate. To build a clear, powerful argument that is grounded not just in data, but in a strong ethical framework.
So let me just leave you with this final thought. In the 21st century, understanding energy, its science, its politics, its ethics, this is not a niche specialty for engineers. It is as fundamental as learning how to read and write. As the next generation of leaders and educators, your greatest task is to build that literacy in others. Because energy literacy is foundational literacy. It's the very language we're going to need to write a more just and sustainable future for everyone.